NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new, more mysterious, more beautiful than humanity's dreams.
In a recent mission, scientists aimed the Webb Telescope at the stunning Whirlpool Galaxy M51. What they found was truly fascinating. They uncovered intricate details within the empty spaces and bright threads in the galaxy's spiraling arms. At first glance, it might not seem like a big deal, but this is precisely the kind of image that scientists have been eagerly waiting for. Join us as we explore the other hidden wonders the James Webb Telescope might reveal. And why is understanding galaxies like M51 so important for our knowledge of the cosmos? The dark red areas in the picture show warm dust making stringy shapes in space. The red spots are light bouncing off fancy molecules forming on dust bits. The orange and yellow zones mark gas around newly born star clusters.
You know, the heartbeat of this galaxy is so rapid.
What do you mean by that?
Well, this galaxy is forming stars at about the rate of the Milky Way, even though it's 100 times less massive.
What secrets are these cosmic threads hiding? The James Webb Telescope used its powerful NIRCam and MIRI instruments to capture these perspectives of the object. Both devices specialize in decoding infrared light from distant stars and galaxies. This image was taken from a distance of 27 million light-years away from Earth. It's part of a series of observations aimed at helping us understand how stars form and the influence of stellar feedback in galaxies beyond our own Milky Way. Discovered back in 1773 by a French astronomer named Charles Messier, the Whirlpool Galaxy, also called M51, has been a famous thing to see in our night sky. It's located 27 million light-years away in the Canis Venatici constellation. But what makes this new picture of the Whirlpool Galaxy so extraordinary is that it was snapped by the James Webb Space Telescope, the most powerful telescope of its kind. This image isn't just a peek into space, it's a journey back through time. It shows the fascinating effects of something called stellar feedback on the galaxy's surroundings. Stellar feedback makes a complex web of bright knots and dark bubbles in space. The European Space Agency, which helped build and launch this amazing telescope, describes these effects. As we gaze deeper into the Webb images, let's imagine what it would be like to voyage inside the Ring Nebula itself. The scene surrounding us is surreal. We're enveloped in a sea of radiant gas and dust, with the massive circle of the nebula dominating the sky. It's a majestic sight, but strangely lifeless. The hydrogen clouds around us glow in shades of red, etching the vacuum with delicate tendrils. In the center looms the tiny white dwarf, the remains of a once mighty star, now just an ember slowly fading to black. Its feeble heat offers little comfort against the cold abyss. We drift through veils of carbon molecules that sparkle vividly before being swallowed by the darkness. What alien worlds lie hidden in these shadows? Could life be secretly thriving in tiny pockets within the nebula's expanse? As we reflect on our own insignificance, adrift in this infinite void, one thing is clear. The Ring Nebula epitomizes the sublime balance of beauty and desolation in our mysterious universe. Back home, there is still so much to unveil. So this photo isn't just a snapshot of a galaxy, it's a snapshot of the universe's history from 27 million years ago. Could stellar feedback unlock the origins of cosmic creation? Stellar feedback is a fancy way of saying that stars release a lot of energy into space, and this energy affects how new stars are born. Understanding this process is crucial for creating accurate models of star formation in the entire universe. Now, about the Whirlpool Galaxy. It has a little sibling that plays a role in shaping its beautiful spiral arms. When the Hubble Space Telescope took a picture of M51 more than 10 years ago, scientists were excited to see what the James Webb Telescope would capture. This observation of M51 is part of a series called Feedback in Emerging Extragalactic Star Clusters, or simply FEAST. The goal of FEAST is to find and study places where new stars are born in galaxies other than our own Milky Way. Before the James Webb Telescope, other observatories showed us glimpses of star formation, but often after the stars had used up their birth clouds of gas and dust. Now, thanks to this powerful telescope, astronomers can see star clusters forming right from their birth clouds in galaxies far from our local group. They can also figure out how long it takes for these stars to change the gas by adding new metals and clearing it out. By studying all of these processes, scientists hope to learn more about how stars are born and how they affect galaxies. The James Webb Telescope, with its advanced infrared sensors, has given us detailed images of things like the Ring Nebula, revealing structures we've never seen before. So, in simple terms, it's helping us unlock the secrets of the universe by showing us things we've never seen before. What a fantastic tool for exploring space! When we first looked at the pictures, we were amazed by the incredible detail. The shining circle that gives the nebula its name is made up of around 20,000 clumps of thick hydrogen gas. Each clump is as heavy as the Earth. Inside this circle, there's a thin line of light coming from complex carbon molecules called polycyclic aromatic hydrocarbons, PAHs. It's surprising to find these molecules here. Beyond the bright circle, we see strange spikes pointing away from the center star. They're clear in the infrared, but in Hubble Space Telescope images, they were very faint. We think these spikes might be created by molecules in the shadows of the ring's densest parts, where they're protected from the star's strong radiation. For example, the JWST captured light that our eyes can't see, called infrared light, coming from the nebula. This helped us learn about the inner ring structure and about 10 circular shapes in the outer parts of the nebula. These circular shapes were a big surprise. They probably formed every 280 years when the central star was losing its outer layers. Normally, when a single star becomes a planetary nebula, this doesn't happen over such a long time. So these rings suggest that there's likely another star in the system. It orbits about as far from the central star as Pluto does from our Sun. As the dying star was shedding its outer layers, the companion star influenced how it happened. Roger Wesson from Cardiff University explained this, noting that no previous telescope could see this subtle effect. The story of how we've studied the Ring Nebula is more than just its parts. It's a symbol of how humans have always been curious and have used new technology to learn more. Back when people first called it a planetary nebula, they had some wrong ideas. Now, with the powerful JWST, we're still learning more. This journey is like how our understanding of the universe has grown. Astronomers Charles Messier and Pierre Méchain found the Ring Nebula in 1779 while they were tracking a comet in the Lyra constellation. And while this discovery is extraordinary, it's not the only marvel that the James Webb Space Telescope has unveiled. The telescope, which sits about 1 million miles (1.6 million kilometers) from Earth, has opened a new window into the cosmos. It's not just about capturing beautiful images, it's about advancing our understanding of the universe's grand tapestry. Consider this. When we first saw these images, we were stunned by the level of detail. The bright ring that gives the nebula its name isn't just a uniform structure. It's a complex tapestry woven from approximately 20,000 individual clumps of dense molecular hydrogen gas, each of them about as massive as the Earth itself. This intricate structure challenges our previous conceptions of how planetary nebulae form. But the surprises don't end there. Inside the bright ring, there's a narrow band of emission from polycyclic aromatic hydrocarbons, or PAHs. These are complex carbon-bearing molecules that we wouldn't expect to find in the harsh conditions of the Ring Nebula. Their presence raises questions about the chemical processes happening within the nebula and the sources of these intriguing molecules. Beyond the bright circle, we see curious spikes pointing directly away from the central star. These spikes, prominently visible in the infrared but only faintly seen in the Hubble Space Telescope images, have puzzled astronomers for years. The James Webb Space Telescope's infrared capabilities have finally shed light on their origin. These spikes likely result from the presence of molecules in the shadows of the ring's densest regions, where they find protection from the intense radiation emitted by the central star. In essence, the James Webb Space Telescope has given us a new perspective on the Ring Nebula and planetary nebulae in general. It has expanded our understanding of these celestial phenomena, challenging existing theories and providing fresh insights into the life cycles of stars and the intricate processes that shape the cosmos. Furthermore, this achievement exemplifies the power of human curiosity and technological innovation. From Charles Messier's first observation of the Ring Nebula in 1779 to the remarkable images captured by the James Webb Space Telescope in the present day, it's a testament to our enduring quest for knowledge. We've come a long way from early misconceptions about planetary nebulae, and with cutting-edge tools like the James Webb Space Telescope, we continue to unveil the universe's mysteries. But the James Webb Space Telescope's mission goes beyond a single nebula. It's a symbol of our relentless pursuit of understanding the cosmos. Its advanced infrared sensors enable us to explore the furthest reaches of space, reaching back in time to witness the birth and evolution of stars and galaxies. It provides a fresh perspective on familiar celestial objects and reveals hidden wonders that challenge our current theories. For instance, beyond its study of planetary nebulae, the James Webb Space Telescope has delved into the realms of distant galaxies and exoplanets. Its ability to capture and analyze infrared light has allowed astronomers to peer through cosmic dust clouds, unveil the birthplaces of stars and planetary systems. It has provided valuable data on the atmospheres of exoplanets, bringing us closer to answering the age-old question of whether we are alone in the universe. In essence, the James Webb Space Telescope is a beacon of human ingenuity, a testament to our unquenchable curiosity, and a gateway to new realms of scientific discovery. It reminds us that the universe is an ever-unfolding tapestry of wonders, and with each technological leap, we uncover a piece of its intricate design. As we gaze upon the mesmerizing images of the Ring Nebula and other celestial wonders captured by the James Webb Space Telescope, we are not merely spectators, we are participants in a grand cosmic journey. It's a journey that transcends time and space, offering glimpses into the past, present and future of the entire universe. Today, the Ring Nebula is like a treasure for space explorers. It's a colorful circle made by a dying star turning into a white dwarf. When we study this nebula, we're not just looking at a faraway thing, we're seeing the past, present, and future of the whole universe. It's a bit weird, but two pictures of the same nebula can have different colors. That's because Webb takes special pictures in a way our eyes can't see. If you look at Webb's original pictures, they're all black. But smart scientists turn this special data into colorful pictures we can understand. These pictures show different parts of the nebula. Webb is not just about this nebula. It helps space scientists explore the furthest parts of space and even looks at the rings around planets in our solar system. It gives them a fresh way to see space. What next discovery are you expecting from Webb? Let us know down in the comments. Until next time.